Welcome to the DIY Honda Garage channel. This presentation covers the Diagnostic Trouble Code DTC P2127, which indicates a low voltage problem in the APP Accelerator Pedal Position Sensor B circuit, specifically known as TP, Throttle Position Sensor E. This issue affects the vehicle's ability to accurately measure the accelerator pedal position, directly impacting engine performance and throttle response. The DTC is confirmed when the failure is consistent and reflects on the Powertrain Control Module (PCM) data. It's crucial to understand the role of the APP sensors, which are responsible for sending voltage signals to the PCM. This process determines the throttle position and adjusts the engine's power output accordingly. In the subsequent slides, we will examine an extensive troubleshooting process to rectify this issue. The APP Sensor B, also referred to as TP Sensor E, is integral for monitoring the accelerator pedal position and sending this information to the PCM. It typically resides near the accelerator pedal assembly, facilitating real-time feedback for engine management. This sensor generates voltage signals that indicate how far the accelerator pedal is depressed. These voltage readings are critical for ensuring optimal engine performance and efficiency. A low voltage reading, as indicated by DTC P2127, suggests that the sensor may not be functioning correctly or that there is an issue in the circuit it operates within. This malfunction can lead to decreased vehicle responsiveness and should be addressed immediately. Understanding the potential causes of DTC P2127 is crucial in the diagnostic process. One common issue is wiring problems, including shorts or open circuits affecting the signal or power voltage. Inspecting the APP sensor connections for corrosion or loose wiring is essential. Another possibility is a faulty APP sensor B, which may fail to produce the required voltage signal. Lastly, problems within the PCM itself can also trigger this DTC. The PCM processes inputs from various sensors, and any fault in this unit could lead to erroneous readings, exacerbating the issue at hand. Each of these potential causes must be systematically tested to isolate the root cause of the problem. DTC P2127 can produce several observable symptoms that indicate a problem with the accelerator pedal input system. The most immediate sign is the illumination of the check engine light, which alerts the driver of a malfunction within the vehicle's electronic systems. Moreover, the vehicle may experience reduced engine performance, leading to sluggish acceleration. Drivers may also notice an erratic throttle response, where the engine does not react proportionally to the accelerator pedal position. These symptoms can severely affect the drivability and safety of the vehicle, necessitating immediate inspection and repair. The first troubleshooting step involves confirming the issue by turning the vehicle's ignition to the on position without starting the engine. Using the Honda Diagnostic System, HDS, check the voltage readings from the APP Sensor B. The critical point here is to observe the voltage. If it reads less than 0.2 volts, the failure condition is confirmed, and you can proceed to the next steps. If the voltage readings meet the expected values, this may indicate that the issue is intermittent, suggesting possible loose connections or corrosion at the APP sensor or PCM terminals. It necessitates further inspection of the wiring and connections to rule out temporary faults before concluding that the system is functioning correctly. In this step, turn the vehicle's ignition back to the off or lock position. Next, disconnect the APP sensor 6P connector to isolate the sensor from the circuit. With the connector removed, turn the vehicle to the on mode again. At this point, you will need to measure the voltage between designated test points of the 6P connector. It is essential to ensure that the voltage reading is approximately 5.0 volts at this stage. If you confirm around 5.0 volts, it indicates that the supply voltage to the sensor is adequate. However, if the voltage does not meet this specification, it will signal a potential issue with the wiring or power feed, necessitating further investigation into the circuit integrity and connections. For step 3, you begin by turning the vehicle off once more. The next part of troubleshooting involves jumping the SCS service check signal line using the HDS. Allow this configuration to sit for over a minute to stabilize. After doing this, disconnect the PCM connector A51P to isolate it from the rest of the circuitry. With both the APP sensor 6P and the PCM connectors disconnected, check for continuity between designated test points of the APP sensor and body ground. Achieving continuity confirms that there is no short in the AP2 wire that runs between the PCM and the APP sensor. If continuity is present, repair any identified shorts in the circuit. If not, proceed to assess further wiring integrity in the next step. This step centers on checking for an open wire in the AP2 line. Begin by connecting terminals A and B using a jumper wire to effectively bridge the APP sensor 6P connector to the vehicle's body ground. With this jumper in place, continuity testing should be performed with the HDS. Check between the PCM connector A number 46 and body ground. If there is continuity, it suggests that the AP2 wire has no breaks or faults. If continuity is absent, this indicates an open circuit in the AP2 wire between the PCM and APP sensor. Repairing this open wire is essential to restore proper functioning of the APP sensor circuit. In step 5, the focus shifts towards assessing the PCM's internal circuitry. Begin by reconnecting the PCM connector A51P to restore communication between the PCM and other system components. After reconnecting, remove the jumper wire from the APP sensor 6P connector. Next, establish a new jumper connection between terminals A and B, which involves bridging the APP sensor 6P connector number 1 and number 3. With this configuration in place, turn the vehicle to the on mode again and check the APP sensor B readings using the HDS. If the reading is still less than 0.2 volts, this indicates PCM malfunction or the need to check for service bulletins. If the voltage is satisfactory, replacing the APP sensor may be necessary to resolve the ongoing issue. The final troubleshooting step concentrates on the VCC4 line to ensure that it is intact. Just like previous steps, turn the vehicle's ignition to off and jump the SCS line again, allowing for a 1-minute buffer. Disconnect the PCM connector A51P once more. Establish a jumper between terminals A and B of the APP sensor 6P connector now to diagnose any potential open circuits. Check continuity between the PCM connector A number 42 and body ground. Achieving continuity signifies that wiring related to the VCC4 system is intact. If there is no continuity, address any open wires found between the PCM and APP sensor. Ensuring the integrity of these wires is critical for preventing future disruptions in the throttle responsiveness and overall engine performance. After completing all diagnostic and repair steps for DTC P2127, it is essential to conduct a thorough verification process to confirm that the issue has been resolved. Begin by rechecking the voltage values for APP sensor B. The readings should align with factory specifications to ensure that the sensor is functioning correctly. Additionally, Verify that the throttle response is operating smoothly and as intended. It is highly recommended to perform an extended road test under various driving conditions to validate that the repairs have restored normal functionality. All parameters should operate within expected thresholds without triggering any DTCs. This final verification is crucial to guarantee that the repairs are permanent and the vehicle is safe for optimal performance. Preventive maintenance is vital to avoid future occurrences of DTC P2127. Regularly inspecting the connectors at the APP sensor and PCM will help identify any early signs of corrosion or damage. Keeping these connections clean and free of debris ensures efficient signal transmission and prevents potential shorts or opens. In addition to visual inspections, it's beneficial to monitor the performance of APP sensors through periodic diagnostics. This proactive approach can catch abnormalities early, allowing for timely repairs and preventing more extensive complications down the line. Incorporating these practices into routine maintenance can significantly prolong the lifespan of the electronic throttle control system. In conclusion, troubleshooting DTC P2127 is essential to ensure safe operation and performance of the Honda Pilot. Understanding the symptoms associated with the problem can help in its early identification, crucially affecting the vehicle's drivability. The integrity of both the APP sensor and associated wiring is necessary for accurate engine control and throttle response. Following the detailed diagnostic steps outlined ensures that any faults are systematically addressed, leading to effective repairs. Regular maintenance and inspection of electrical connections play an essential role in preventing such issues from arising in the first place. This comprehensive approach underscores the importance of diligence in vehicle diagnostics and repair. Please like and subscribe to the channel. See you next time!